This presentation explores the case study of a bicycle and is presented by Dominic Caulfield and Jack Bunnell. A bicycle is a machine that is used in order to provide transportation for a rider. The bicycle is powered by a human rider who uses their legs in order to spin the pedals. The pedals are connected to the wheel with a chain, and the bike is steered with the handlebars. The three components on the bike that we will be exploring in this presentation are ball bearings, springs, and sprockets. The mechanical advantage of the bike can often be adjusted with a gear shifter that shifts the chain to a different sprocket. The mechanical advantage of a bike can range from 0.7 to as high as 7. Here is a photo of our system diagram. In this photo, the spring can be seen in green, the sprockets can be seen in blue, and the bearings in red. The bearings used in this bike are ball bearings, and they allow the wheels, sprockets, and handlebars to spin. The blue sprockets in the front and back are connected via chain and allow the bike to adjust the mechanical advantage because the front sprocket has a set of differently sized sprockets, allowing the user to adjust the gear ratio by shifting the chain. The spring, shown in green, provides suspension for the rider by dampening shocks that are created from bumps while riding.
Ball bearings are commonly used in bicycle designs as they provide a low-friction rolling element that allows for smooth and efficient rotation of mechanical parts. In bikes, ball bearings are used in the wheel hubs, bottom brackets, and headsets. They work by reducing the contact area between the rotating parts, which reduces friction and wear. In the bottom bracket, ball bearings are used to support the crankshaft and pedal spindle. In the wheel hubs, they enable the wheel to rotate smoothly on the axle. Similarly, in the headrest, they allow for smooth rotation of the fork and handlebars. Proper selection and placement of ball bearings are crucial for efficient and reliable operation of the bike. Parameters to consider for bearing selection include the forces, such as the weight and potential bumps, as well as the number of cycles and speed they will need to endure. Springs are important components in a bicycle design that provide suspension and shock absorption. They are commonly found in suspension forks, seat posts, and rear shock absorbers. The springs work by compressing and rebounding, absorbing impacts and vibrations from the road or trail. This helps to improve the rider's comfort and control, as well as reduce the strain on the bike's frame and components. The type of spring used on a bike can vary depending on the specific application and desired performance characteristics. Common spring materials include steel, titanium, and various types of alloys. Proper selection and tuning of the springs is critical for optimal bike performance and rider comfort. Sprockets are a vital component of a bicycle's drivetrain that work in tandem with the chain to transfer power from the pedals to the wheels. They are found on the rear wheel hubs and the crankset. The size and number of teeth of the sprocket determine the gear ratio, which affects the amount of torque and speed that can be produced by the bike. The chain rides on the teeth of the sprockets, transferring power and allowing the rider to change gears by shifting the chain between different sprockets. Sprockets can be made from a variety of materials including steel, aluminum, and titanium, each with their own different properties and benefits. Proper selection and maintenance of the sprockets are crucial for smooth and efficient operation of the bike's drive chain, and with the range of gear ratios best selected for the bike's usage and required torque and speed.
This photo shows the FEA of a bike frame. Most new bike frames are made of aluminum because it is lighter and often easier to work with. But because the bike receives many stress cycles during operation, it would be best to make the frame out of steel if infinite life is desired.